welcome y'all back to some more algebra. Now, this is the second part of the 1.1 section, intro to graphing. There's one thing before we get started in the new stuff. This is still new technically, but there's one thing I did forget to talk about that as I was doing the homework, like, oh, I meant to skip this wrong because I forgot it. We're gonna talk about a squared x right here. So we've been talking about graphing linear straight lines, but sometimes you get what's called quadratic, which means it has some curves. So to go about this, the best thing kind of do here is, well, let's set up a table. Let's start out with some negative numbers, kind of get an idea. -3, -2, -1, 0, 1, 2, 3. These are all values of x. So if I put a -3 right here, -3, -3 square is, y'all, this would be my y's, +9. If I put a -2, -2 times -2 gives me a +4. Put a -1, -1 times -1 is 1. If I put in a 0, 0 square is 0. If I put in a 1, 1 square is 1, 2 square is 4, 3 square is 9. Look at this right here. These, even though these values were negative, these stay positive. So let's kind of graph that. We'll start with our 0, 0 right here. Like we said, if you get a -1 on the x, what's the value of y? +1. If it's -2, you get a +4. 1, 2, 3, 4. If you get a -3, you get a +9. And that happens in the same way on the other side. If you have a +1, you get a +1. If you have a +2, you get a +4. Get a +3, you get a +9. This is what we call quadratic. It curves, goes down, and it goes back up. So the best way right now, unless you like just by memory, remember a lot of this from Algebra 2, the best thing to kind of do when graphing some of these is to just kind of do what we call a t-table right here. This is our t-table where we do our x coordinates and then do our y coordinates. Now remember, did we talk about it before? Not as much, but I'm going to talk about it now. We have what's called an independent variable. Independent variable and a dependent variable. Now, what do you think is the difference between the two? What does it mean to be independent? To be independent means you don't need something else to determine what you are or to do what you are. Dependent variables are dependent on something else to help define it. Well, in a system of equations, in graphing, in quadratics, your independent variable is your x, and your dependent variable is your y. Y changes depending on whatever x is. It's not vice versa. Now you can tell me, hey, I want to have the value of 15 for x. What will y have to be? That's a different thing. Then that will tell you what y has to be. But that's because x has to be. Y is dependent on x. So you can say I want the value 15 for y, but that means I got to figure out what x has to be to make sure that's 15. So remember that independence is your x value. It's not that usually control. And then when you think about this, another way to kind of think about it is time. If I'm graphing something that's happening in real time, the value of x is always, this is where you determine time, 1 o'clock, 2 o'clock, 3 o'clock, or January, February, March, April. This can be anything else. It can be money. It could be sheep's raised. It can be apples picked. It doesn't matter. Time, we can't control time. That is independent of us. So this is kind of a good way to think about time is your x. Everything else is your y. Money, food, cars, doesn't matter. That's all dependent as far as time. All right, y'all? Okay, now let's move on to our new stuff right here. We're talking about the distance formula. Now, this is the distance formula. Usually there's like a D, like D equal distance equals this formula right here. Okay, so let's kind of break it down. This is square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Best thing to do is just write it down. Great thing about formulas is it's the type of thing where you just plug things in and they work. That's what you're trying to do. The hardest thing, I guess the most difficult thing to remember is what is x1, what is x2, what is y1, what is y2. This is the first set of ordered pairs. So this will be our x1, y1. This is the second set of ordered pairs, so this would be our x2, y2. So let's plug those in. So as we plug this in, we'll say d equals big old square root x2 as we have right here. So we got -4. Now understand you carry the sign minus, doesn't matter what x1 is, it's minus and then minus whatever x1 is. In this case 2, quantity square, plus, now we don't distribute the square, we simplify in the parentheses first. Y square, y2, which is -3, minus y1, in this case is 4, quantity square. So again, we work the inside first, so -4 and -2 gives us a -6. -3 and -4 gives us a -7. Good, good, good. So now we go ahead and square it. So -6 and -6, positive 36, plus -6 is -7 is positive 49. You still have the square root. Now let's add them up. Now you can't square them individually. You have to kind of put them together. So 36 plus 49 gives us the square root of 81. Now 81 does not have a square root, or at least not a perfect one. It just stays as that. If you want to like give a guesstimate per se, you can round that off to say that's 9.2. It's 219544. We'll go 22. But this is what I want most of the time, unless it tells you to round, leave it in radical form. This is a great answer right here. Okay, so this is a distance formula. All you gotta do is the first set is your x and y, the second set is your x2, y2. x1, y1, x2, y2. Plug it in. Let's look at the midpoint formula. So the midpoint formula is used to find just that, the middle point in between a segment. So you have a segment that, find the midpoint of a segment whose endpoints are that and that. So those are your endpoints. This is your x1, y1, x2, y2, and then the middle is your xm, that's what I like to call it, x midpoint, y midpoint, like x and y midpoint coordinates. So as it shows right here, x1 plus x2 over 2, that gives you ultimately your x midpoint coordinates. So this equals this down here, and y1 plus y2 divided by 2 gives you your y midpoint coordinates. You're going to get an ordered pair when you do this formula. So let's go ahead and try that. So this would be our ones, 2's, 2's. Let's plug those in. So we got x1, -4, plus x2, which is 2, all over 2, comma, y1, which is -2, plus y2, which is 5, all over 2. -4 plus 2 is -2, so this gives us -2 over 2. And -2 plus 5 is +3 over 2. If you can reduce it, you can. So in this case, you can. You get -2 divided by 2, you get -1. And then 3 over 2, I will leave it as 3 over 2. This is your x coordinate, x midpoint, y midpoint right there. Let's do it with fractions this time, huh? Let me go complicated here. So same thing. This is our x1, y1, x2, y2. I'm going to change colors. So we're going to do same thing. Plug it in. -1 over 6 plus -3 or 2 over 3 all over 2 comma y1 -3 over 5 plus 5 over 4 all over 2. Best way to kind of go about this is common denominator. So the common denominator between a 3 and a 6 is a 6. So we multiply this by 2 and this by 2. So we get -1 over 6 minus 4 over 6 all over 2, comma, common denominator is 20 here. So multiply this by 4, this by 5. You end up getting -12 over 20 plus 25 over 20 all over 2. Combine this, -1, -5, -4, you get -5 over 6 over 2. And then you get comma -12 plus 25 would be positive 13. So positive 13 over 20 over 2. Now, remember these fractions right here. When you have that, when we were doing this, you can bring this to the side because you're saying we have negative 5, 6 over 2. You have negative 5 over 6 over 2. Now you're saying divided by 2. Remember, we can put it to the side, say yes, divided by 2. Well, we can't divide fractions, so we do this multiply by reciprocal. So it'll be negative 5 over 6 times 1/2. So we can do the same thing with this is our x coordinate, and our y coordinate be the same thing, 13 over 20 times 1/2. You can't reduce here, so we multiply. We get negative 5 over 12, comma, and same thing right here. You get 13 over 40. And this is your coordinates, your xy coordinates. Seems like a lot. I know, I'm sorry, but it's just because I did every step slow. Lots of these you can do by in your head. Most of you guys are very smart that you're able to do this by your head. But I did step by step so you can see where I got every single number and there's no confusion. Last thing here is the equation of a circle. Now, this is kind of cool. The equation of a circle. Understand, the value of a circle is not what's inside, but it's every single little point that goes around here. Okay? So what we are actually finding when an equation of a circle is the distance from this to that particular point at any single moment here. The value of h and k is actually your center. In a circle, you have a center, remember? That's represented by h comma k. Our xy is any single point on here, any single point right here. This right here is just one fancy version of the distance formula. Because let's look at this, and let's look at this right here. The difference is if I square this side, I end up having d squared equals, the radical's gone, x2 minus x1, comma square, plus y2 minus y1, comma square. This square plus this square plus this square, hey, that's just your equation of a circle. So we're giving more purposes to the x2 or the x1 and y1. Our starting point is the center of a circle. Okay, so that being said, if I want you to say, find the equation of a circle who has a radius 5 and center 3, comma, negative 7. All you're doing is just giving me this equation, literally with this information in it. So the things that will always have numbers in it, or should always have numbers, is your h, your k, and your r. Now we will simplify this, but as we set this up, we'll say, hey, your x is x, so it'll be x minus whatever the value of our x coordinate in our center, or h coordinate, be 3. So x minus 3 quantity square plus y minus whatever this is to be, in this case, negative 7 quantity square equals the radius 5 square. Now, are we done? Not yet. Let's go ahead and simplify things. So this is good. That looks fine. So x minus 3 quantity square. But we got to get rid of this negative negative. So negative be y plus 7 quantity square equals, and let's go and square that, 25. More than likely, you'll see it like that. Sometimes they might leave that as a 5, square root of 5 right there. But they'll more likely go ahead and square that whole number right there. So that being said, if we look at the original equation, if you have negatives right here, the value of your h and k's are positive. But when you have a positive here, that means that value of one of those h or k was originally a negative. Let's practice graphing these. You're going to have to graph these. Graphing circles really isn't that bad. The two things you got to know is, what is my center and what is my radius. Those are the two things I need to know. Remember, this is your h, this is your k, and this is your r. In this case, it's r squared. Okay, so like we said earlier, since these are positive, my h and k will be opposite of that, a negative 4 and a negative 5. Since this is r squared, r squared equals 9, we're going to square root both sides. R equals 3. That means my radius is 3. So we start with our center. Let's graph that. So negative 4, 1, 2, 3, 4, 5, 4, and then negative 5 on y down, 1, 2, 3, 4, 5. Okay, so that's my center. From there, the best way to graph these and do your radius. Radius up, 1, 2, 3. Radius down, 1, 2, 3. Radius left, 1, 2, 3, and radius right, 1, 2, 3. And then just do your best to make a nice little circle. It's kind of hard to do a digital circle on here, but I'm going to try my best. There we go, I think. There we go. It's all right looking circle, isn't it? We'll say yes. Yeah, you do your 4 points and then just make a nice little circle connecting those points, assuming this is a circular. Some people, I would say, some people had a bad habit. They get kind of lazy. They're like, oh, it's just bam, 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 bam. That is not a circle, y'all. You didn't even try in that case. But let's try and make a nice circle when we graph these. But hopefully this helps y'all. If you need any help, please, please, please let me know. Do not fall behind, okay? Have a great day. Bye.